Welcome to Saturn, the sixth planet from the Sunday and the second largest planet in our solar system. Saturn is a gas giant adorned with a magnificent system of rings that sets it apart from every other planet. Let's venture up close to these rings to uncover their secrets as we soar among them. As we draw near, the true grandeur of Saturn's rings unfolds. Contrary to the single band we see from Earth, Saturn boasts a complex ring system consisting of 7 main rings named D, C, B, A, F, G, and E, listed in order from innermost to outermost. These rings are further divided into thousands of smaller ringlets, each with its own story. Starting with the innermost D ring, we find a faint and narrow band closest to Saturn's cloud tops. It is tenuous and somewhat elusive, composed of fine dust particles. The proximity to Saturn means it is heavily influenced by the planet's gravity and atmosphere, causing particles to spiral inward and disintegrate, like a continuous celestial waterfall. Next is the C ring, sometimes known as the crepe ring due to its semi-transparent appearance. Though not as bright as some of the other rings, it holds intricate structures known as plateaus and gaps. It is a region rich in mysteries with variations in density that have intrigued scientists for decades. Moving outward, we reach the B ring, the brightest and most massive. This ring captures our imagination with its density and brilliance. Here, particles range from tiny specks of dust to colossal chunks comparable to mountains. Imagine floating beside an enormous iceberg adrift in space, reflecting sunlight across the darkness. The B ring is also home to intriguing features called spokes, ghostly radial markings that appear and disappear unpredictably, likely due to Saturn's magnetic field interacting with the ring particles. Beyond the B ring lies the famed Cassini division, a dark gap around 4,800 kilometers to 983 miles wide. This isn't empty space, but a region with fewer particles, shaped by the gravitational influence of Saturn's moon, Mimas. The resonance between Mimas and the ring particles clears out this space, a visual example of the subtle yet powerful forces at play. After the Cassini division is the A ring, the outermost of the dense main rings. The A ring is known for the Encke and Keeler gaps, narrow divisions within the ring caused by small moons orbiting within them. For instance, the moon pan carves out the Encke gap, while Daphnis maintains the Keeler gap. These moons act like cosmic shepherds, keeping the gaps open and influencing the ring material around them. As we venture further, we encounter the F ring, a narrow dynamic band full of twists and knots. Here, the shepherd moons Prometheus and Pandora play a cosmic tug of war, their gravitational forces creating kinks and clumps that continuously evolve. It is a living illustration of gravity's artistry. Beyond the F ring lies the G ring, a faint and dusty ring that is difficult to observe from Earth. It is believed to be formed from material ejected by micrometeoroid impacts on small moons. The G ring may not be as prominent, but it adds to the complex and delicate structure of Saturn's rings. Finally, we reach the E ring, the outermost and widest ring, extending from Mimas's orbit out to Titan's. Unlike the dense inner rings, the E ring is diffuse and primarily composed of microscopic ice particles. It is continuously replenished by the icy plumes of Enceladus, Saturn's moon famous for its geysers. Enceladus ejects water vapor and ice grains into space, feeding the E ring and hinting at a subsurface ocean that could harbor conditions suitable for life. But what exactly are these rings made of? Predominantly water ice with traces of rocky material, giving them their shimmering, icy appearance. The particles orbit Saturn at incredible speeds, each following its path dictated by gravity and the laws of motion. One of the most frequently asked questions is, how thin are Saturn's rings? Despite their expansive width, spanning up to around 282,000 kilometers, 175,000 miles, the rings are astonishingly thin, estimated to be between 10 to 100 meters, 33 to 328 feet thick, depending on the ring and location. It is like spreading a sheet of paper over an entire city. The contrast is truly mind-boggling. People often wonder, why does Saturn have rings? While the exact origin remains a fascinating mystery, prevailing theories suggest they could be remnants of moons, comets, or asteroids that disintegrated under Saturn's immense gravity. These catastrophic events scattered debris around the planet, which eventually formed the rings we see today. Are Saturn's rings permanent? In cosmic terms, they're transient. The rings are gradually losing material as it is pulled into Saturn, a process known as ring rain. NASA estimates that the rings could disappear in about 100 million years. While that is an unimaginable time span for us, it is a fleeting moment in the life of the universe. This brings us to the question, how old are Saturn's rings? The exact age of Saturn's rings is not entirely certain, Recent estimates suggest they're relatively young, perhaps between 100 to 400 million years old, but they could be billions of years old like Saturn itself. It is possible they might have formed during the age of dinosaurs on Earth, emphasizing how dynamic and ever-changing our solar system is. As we continue our journey, I can't help but reflect on the delicate balance that creates and maintains these rings. The interplay of gravitational forces, the contributions of moons like Enceladus, Mimas, Pan, Daphnis, and others, along with the ever-present solar influences, all work in harmony to produce this celestial masterpiece. Saturn's rings are a natural wonder, a complex dance of particles large and small, each playing a part in a grand performance that has captivated observers for centuries. They're a reminder of the intricate beauty that exists beyond our world and a reflection of our place in the cosmos. Did you know that Saturn has 146 moons and counting? These moons not only add to the planet's allure but also play significant roles in shaping and maintaining the rings. Each moon is a world of its own, with unique features and mysteries waiting to be explored. Thank you for joining me on this journey. I am glad you could be here. If you enjoyed this video, feel free to hit the like button or share this video with other curious minds. I would also love to hear your thoughts in the comments below. Tell me, have you ever witnessed Saturn through a telescope? Your interactions with this video truly go a long way in helping others find and enjoy these adventures through space. I would also like to thank this amazing community for your ongoing support. I appreciate you all. If you'd like to join me on more adventures soon, feel free to subscribe and hit the bell icon so you don't miss the next one. Until our next adventure, keep exploring, keep questioning, and never lose your sense of wonder about the universe that surrounds us. Thanks again. Until next time, take care and be well.